see Heyman wandering in. All right, Heyman's finally here. We can start. All right, is it time? All right, guys. So this is what I was supposed to talk about. Oh, and by the way, there's like, not a large number of us here. So feel free to question, comment, ask what I was really trying to say when I mess up saying it, kind of like with the ops session when I tried to explain serverless in the wrong way. This is what I was supposed to talk about, PowerShell.NET service architecture. That's kind of what I'm talking about. I'm really going to talk about is the cloud at the moment and my current understanding, because the last 7 months I've been playing around this place called AWS, Amazon, and 22 years in Microsoft prior, and so I just had a little different perspective. A few more things got a little crisper for me, and so I thought I'd mention those along the way. Then we'll talk about serverless with PowerShell. That's the AWS lambda that people are aware of. And then we'll have a futuristic look a bit at a PowerShell DSL that we have a prototype of and we're playing with. People might have played with. All right, so that's the agenda, blah, blah, what I learned, focus. Yeah, it's cool. All right. Here's what I learned. Here's the first thing. First is when I've heard over the years people talk about, oh, you lift and shift, and then people say, well, sometimes you get benefit and sometimes you don't. And sometimes they've even said, hey, our costs have gone up, right, as they've done a poor lift and shift. So what I talk about is, done right, you have substantial savings. And here are some exact examples. Actually pretty darn good. US Navy got a 60% reduction in cost. Telenex got 75% performance improvement at 60% less cost, and so forth. So these are reasonable results. These are not perfect implementations. Some of them were done in months. But the fact is that over time, what's happened, and people don't, I did not have this as in focus. AWS has been doing this for a long time. We probably got a jump start of 6 or 7 years on other people in this space. And so they've been refining things. Since 2006, they've reduced costs for their cloud platform architectures 67 times. What that means is every other month, if you're leveraging the AWS cloud, and I can't speak to the other clouds, but if you're definitely leveraging the AWS clouds, every other month, you get a cost improvement without any effort, right? Everybody remembers Jeffrey's session a little bit about trying to take advantage of other things, right? It was the cost, get rid of context. It's going to be really hard for anybody else to match that if you're running your own data center. Now, larger companies like us can get economies of scale. It's really not so much contract negotiation. We're just continually refining. We actually have cost metrics. Each team has their own perf metrics, their own cost metrics. We reduce them, and then Amazon's always had a policy of lower costs. That's what it started with Amazon.com. And AWS sort of continues that. So we're used to running businesses a little lean. So that's a continual basis. The third point I thought was really interesting for me, and that says, hey, and this came up as I was talking to another Australian company, actually, a gas company. And we were talking to their CEO and their CIO and everybody. They'd come to their executive briefing center and talking through the cloud. How do we make the transition? What do we do? How do we think of all this? What are we going to get benefit from? And at the close of the day, they sort of were thinking through a summation of what the benefits were going to be. And we came up with 3 or 4. We'll go through some other ones. But one of the ones that hit home for me was this notion I'd call fine-grained OpEx. So we've gone from CapEx to OpEx, capital expenses to operational expenses. Operational expenses being variable, you pay for what you use. That's the whole elasticity benefit of the cloud. I'm assuming everybody's got the cloud basically in focus, so I'm not trying to repeat that stuff. I'm just showing you what I thought was a little interesting when you dig under the covers, the next layer. What I noticed was that it turns out, but you not just have variable operational expense, you actually have fine-grained control. There's a commandlet. The budget commandlet is the noun, BGT budget. And you can have like tons of settings. You want to control how much network you're paying for. You want to control how much compute you're paying for. Do you want to control which instances? Do you want to control when they're on, when they're off, how long they're on for, how long they're off for? You have all these incredible fine-grained OpEx controls. So now you can really refine exactly what you're willing to pay for and what you're not willing to pay for. Does that make some sense? It gives you a whole new set of controls. So you've not only shifted it from cap to OpEx, you've actually said, oh, and we can get really smart about this. That's kind of a, so therefore, people get benefits.
Kenneth,
Yes?
have you found that, or have you learned anything around like what it takes in an organization to build that muscle? Because the shift from CapEx to OpEx, and then to that fine-grained tuning of the OpEx, right? That's a completely different set of budgeting muscles.
Yeah. I would say the digital transformation is a transformation, which is, you know, and there's no end around that, right? No matter what you do, you've got to really think through organization, which is why I thought that the CIO that we were talking to was being very thoughtful. He goes, okay, how do I get my people trained? How do I get them to understand how to think in this different way? You know, how do we, and he kept trying to come back to it on a practical basis. What are the next end steps he could take? So I think there's a, I do think that one of the things that helps organizations is to get this kind of thing in focus, just as an org and as individuals. And then they're able to say, oh, okay, I'll play with it and the experiment. So experimentation is necessary.
So they push some like some budgeting thinking down and the responsibility and cost down then to either product teams or different teams that were.
We do in ours. We do at AWS. Yeah, we do at AWS. We report on it, but we do it. But I assume that would be a best practice to have because if you're going to get the fine grain, you know, the CFO guys, they're not going to know. You know, this has got to become an us thing. This is it's like, I don't know, it's not DevOps, it's company ops or something. You know what I mean? It's a you got to all work together. All right, that was one. Innovation turns out to be the second big one, and this is the one. You bring them into the store with the cost reduction. When they leave, they better get this one in focus. So just to be clear, in 2011, this is 5 or 6 years after AWS started, we produced 80 new, significant new features or services. You got it? Which is actually a fair chunk of change. Last year, we did 1,430 new. That's not cumulative. That's actually in addition to the prior 1,000 last year. If you take a look at that, what that means is for the last 2 years, 2016 and 2017, we have innovated more than we did for the existence of AWS before. Now here's the trick. This goes back to this leverage point. It's like, how are you going to do that at a small company, at a medium company, at a large pharmaceutical company? It's not going to happen. There's only so many companies in the world that can afford to have the equivalent of a Microsoft Research Center or an AWS, what AWS does. It's just this, it gives you a hockey stick of innovation. And what's cool about the innovation is it's available immediately to you to use. Now, you have to figure out how to use it, right? That's the problem. In fact, that becomes the new problem in my mind is actually a strong learning culture becomes vital in this new world because you got to figure out, okay, how do I take advantage of AI? How do I take advantage of the machine learning? How do I take advantage of voice, right? I mean, Alexa, right? Voice. Now we have function as service. We'll talk a little about just one of these N new features and capabilities. So when I talk to those guys, it's like, guys, you can go ahead and innovate all you want to, but if you don't take advantage of all the innovation we're doing, you're going to fall behind a competitor if they do. Because there's no way you can compete with us for all that. It's just way too much. Last 2 years, more than from the beginning. That's the list, if you want an eye chart. In fact, one of the problems we've had, just one of the challenges you actually have once we have so much is how do we get people's head around what it is? How do we get the training? How do we make sure they get the right allocations? That's kind of the next world. Okay, so talked about 67 times price reduction, fine-grained OpEx, taking advantage of the new features, getting leverage out of there. The other part is, and this is just, we knew this going in. This wasn't horribly a surprise, but it's worth iterating, is that operational excellence is just absolutely vital. It is core to the business in this case. It's not always core to other people's businesses. It's core to our business. And so we spend enormous time on that. If something goes south, everybody stops. We take care of things. It is the most vital thing. And I can't tell you the number of layers of security. We have great data, but in order to get another piece of data, I've got to go get a ticket, which gets approved. It's a human who actually approves it for me to access that data. You know what I mean? They're very, 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 very careful about security. All right. We talked a little bit about this. Let's hit this one a little bit, which is the other aspect of it is agility. We already know that. That's the elasticity, right? You can grow, you can shrink. You already have capacity available to you, so you don't have to have, shift the trucked in the servers to have your own capacity. Everybody's got that in focus. I would say the two things that actually just worth pointing out is is that because all that compute power is instantaneously available to your developer, there's an opportunity for them to experiment and be much more agile. Tear things up, take them down. Not a lot of cost associated with it, right? Goes back to the OpEx and the fine-grained OpEx. Not a lot of cost, you try things out, you got the whole free tier thing. And so experimentation actually, I would say, is significantly enhanced when you start playing in the cloud. Along with, of course, leveraging the innovation, right? And then this global deployment. There's like 55 availability zones across 18 regions worldwide. Each availability zone has one or more data centers. It's like insane. You can go global in no time. All right. All of that leads us to this point I was going to talk about down here, which is adoption. And that's just because the adoption rate is the fastest we have seen. AWS was the fastest, the IT vendor, to get to $10 billion a year run rate in the shortest time period, right? Shortest time period to $10 billion. And that's, of course, gone up since, right? And we're not alone in terms of growing fast, right? The area is growing fast. The point here is it's kind of a tide. The tide rises, and if you're floating, if you're riding the tide, you rise with it, right? If you've got weights on, you're going to drown. So rise with the tide. Don't get drowned by the tide. It's coming. All right, I'll come up with a better example next time. A less graphic one. You got a choice. Rise or sink. This, I just thought I'd mention. This is the .NET Core usage. Talk about adoption and newer technologies on AWS. I got to get permission to show this one. But notice there's no numbers here. But this is 0. That's 0. We'll call that 1. 1 times n, right? 2 times n, 3 times n, 4 times n, 5 times n, 6 times, 7 times n. This is February of this year. What that means is that .NET Core on Windows has grown 2x in the 6 months from February to August. .NET Core on Linux has grown, right? Started off at 2x, is now at like 6x, right? It's at 3, and so it's growing very, very rapidly. This goes back to my point about the tide. It's a train. Get on it. Follow it. Don't be shy. Take advantage of the innovation. We talked about the learning culture in passing. This is it. Also worth noting is that the Linux is running about 70% of the .NET Core executions, right? There's about 30, so people are actually shifting over. It's having the effect one thinks. I'm told that the PowerShell core had like 84% on Linux or something like that. Pardon? About 80%? Yeah, so similar notions.
Did you have any visibility as to whether that was mostly workloads in containers?
I can't speak to that. Visibility and ability to speak is a little different. I will point out that if you pay attention, you can see that .NET Core 2.1 on Lambda shipped about that time. Just happens. All right, so that's it for the cloud. Questions, thoughts? Hopefully that was useful, at least going through some of the original stuff. I just thought I'd share what I figured out the last 7 months. It was just a refinement of it. All right, function as a service. This one, we got time. All right, so this is what Jeffrey told us already today, this morning, right? This is my my simplified version of it in terms of the look. That's the basic one. It says, look, you got your core value, which is differentiated value delivered to the customers. Actually, all those are keywords, right? And then you have the mission critical access also, right? Everybody's got this down. We've memorized it. Okay, I shifted the words a little bit, and we'll talk through a little bit. So just because my brain is small, so I can only keep track of so many words and differentiated is too high. There's vital and there's valuable. And this column is the valuable column. It just says this is high value. Could use the word high in there. This is high value. This is the vital axis. Does that make sense? And so if it's up on the top, so core is vital and valuable. Context is it's vital, but it's not really valuable for you to spend a lot of time on. This goes back to leverage this. Why does anybody else do anything here? This is valuable, but it's not vital. You can get value out if you get extra resources you can spend down here and throw them at it, right? So this says, hey, if I can save out of there and put them here, I might not be able to put them all here. You know, there's the whole infinite man month, problem, right? Mythical man month problem, And this is like neither. Right? Don't go there. So then then I sort of mapped it to the slide we did before. And so how did that work out? Well, if you take a look at it, this is my theory. So you're welcome to disagree with it, obviously. But it says, hey, look, when you look at the actual mission critical stuff that is core, what do you care about from the prior slide? Operational excellence, because it's mission critical, right? You want to leverage ours. Really, really pretty good at it. In fact, I don't know, I didn't spend so much time on it, but did you look at the Amazon Route 53? The SLA is 100%, right? So if you didn't, I flipped through that slide pretty quickly. But if you actually take a look at it, you'll see the 99.99s and the 99.9s. That's non-trivial, right? That takes work to do and a little bit of focus. So operational excellence is high value. Take advantage of ours. This is where the innovation comes in, right? Last 2 years, more than we'd ever done before, and we were innovating already rapidly before. This is where the agility comes into play. So that's the quadrant where all that stuff really, really lights up. If we take over here, the innovation and context is not that interesting. The agility is not that interesting. What's valuable there is operational excellence and a variable cost. I can control those costs, the fine-grained cost, right? I can reduce it, I can refine it. I can spend the money I need to, save it, and actually put it somewhere else. That's kind of the theory here. The next thing says, okay, down here I've got innovation. What's important here? Well, innovation, because I want to take advantage of it. Agility and the variable cost, I think, actually comes in value here too. Why does variable cost come in value here and not here? Because this is worth the money. And this says, if I got just a little extra, I can do something cool. So you want that to be highly variable, right? That's where you want it to say, okay, I don't have to spend a lot to get some good value out of it. And then the right quadrant, just don't. Just avoid that quadrant at all. Anyway, different way of thinking about it. Now, the reason I actually went through that was to say the extreme case, there you are. The extreme case of this quadrant right here, this operational excellence, innovation, agility, the extreme core essence is if all you have to write is the one line of code that does the exact one thing you wanted. And you don't have to worry about anything else. You don't have to worry about deployment. You don't have to worry about patches. You don't have to worry about updates. You got rid of worrying about a data center. And you really could just pretend that the code existed in an amorphous cloud somewhere, which you don't care where it existed or how it existed, right? That's the extreme case of pushing out this context and focusing only on value and core. And that's what the serverless gives you. And there's a lot of different terms for it right now, so I put a few up there. One says there's serverless, or there's functions as a service, which is a way of leveraging a serverless concept. There might be other ways of leveraging a serverless concept. And then AWS Lambda is a particular instance of it. This gives us the opportunity to focus extremely hard on the value, and everything else is handled for you. It gives you the ultimate leverage. When we first did PowerShell, we used to talk a lot about how do we get leverage, leverage, leverage. This is how you get leverage. All right. However, it is a little different when you're programming it than what we're used to. We're used to sort of a more linear programming model, and this is not that, right? in the serverless paradigm, you have some code to run. Now, within that code, it could be your normal linear programming model. That's all good. But when it runs, how it runs is completely different, right? Your piece of code is not necessarily getting invoked by some hierarchical structure on top of you. Why? It's being triggered by an event. You can also do an invocation, but something is triggered. So you got a piece of code to run, and you have a trigger that's actually going to run that code at a time that you don't specify, right? At a time now it could be a queue, a time-based trigger, blah, 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 but in the end, it's really unknown to you, the author of the code. And the last part is permissions. You don't want everybody able to run that code. This goes back to security, and this is the part that I think is not often talked about well enough in functions as a service land or in functions land, is that you really have to only allow certain people certain permissions to do that. We'll show you what that looks like. So today, and it's early days here, okay? This is the near future, we'll call it. You can do it right now, right? The code we run today, hopefully demos run, will be running. It'll be real code, productionable, all that stuff, have error handling mostly. So it's got good stuff, but there are edge cases. It takes a little while sometimes for cold starts. There's some things you have to worry about. It's useful if the code is idempotent, because it might be run again because it's on a trigger. That's not necessarily something people think about, right? Right now we do spend a little bit of time setting up the structure for the triggers, right? We'll go through what that code looks like. It'd be great if that was all simplified, and it will be, right? Directionally, there's no question. Directionally, you got to go there. All right. Blah, 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 blah. Okay, we'll actually get to code finally. Now, before I actually get to code, this is actually the one code we want to run, just one line. We're going to have a lot of other lines around it set up. This is actually a find, and this is the image recognition engine. So this is going to leverage the AI of AWS, right? And it's going to take a look at a few images that are in a bucket, which is what the simple storage service calls their containers, right? It's going to take a look at these images, and then it's going to generate a set of labels. And it's going to attach them to those images that are in the bucket. Does that make sense? You with me? So we're going to take a bunch of images, we're going to inspect them intelligently and say, this is a human, this is a walrus, whatever it is. And then I don't have any walruses. Sorry. Okay. Let's see what we got. Now, it's going to suddenly get a little complicated. And drop out of here. All right, so see, this is the 4 bucket for each one right here. This is the code we're running right here, right? Find, rec label. Everybody with me? It's exactly the same thing. And we'll take the tags, and then for each one, we're actually going to write it out to the object. So the object is actually labeled with a tag. That's all it is. Okay, how do we actually do that? Well, the first thing we're going to do, remember I talked about permissions? The first thing we're going to do is we're going to create a role, because we want to attach the role to all these different elements in this Lambda function. So what does this do? Create role, my function role. Get the name of the role. Well, it just creates it in the end. That's all it does. It simply says, assume the role. This is the policy. Hey, we want to allow it to talk to Lambda. And there it is, new IAM role. That's the entire code. So if we come down here, no, I do not want to update in the middle of the demo. Thank you. Jeff almost updated just a while ago. He was fixing a problem that I had a brain fart, so. Make sure I've got this right. Dash, role name. I do love PowerShell tab completion. That's for Singapore. That's all I That's the name of the airport. How did you guys mind? All right, demo role. I think I've got this right. Whew. Now, we've actually tried to write this code reasonably well, and we're happy to share it out wherever it is we're sharing things for people. So it's actually checking to make sure we got everything installed. We've got the AWS module installed. If not, it installs you for you. It takes care of all that stuff. And there we are. I've got a role. Now, if I come here, you can close your eyes, Heyman. We're about ready to show GUI. Yeah, sign in. Blah, 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 blah. Roles, right? If you want to check to make sure I'm not lying, there's the role. There's the syn demo role. Got it? So that's all we did. We created a role. Okay, now we've got something to work with. What are we going to create and deploy a lambda function? How are we going to do that? It takes just a little bit to go. Well, and we're going to attach permissions to it. See, we have that role. There's the function name. Syn demo fun. And I'll do a role. Oh, I don't know. Syn demo role. All right, I think that'll do it. All right, what are we doing here? Let's go through a little bit. Oh, by the way, we could specify different regions. I'm just lazy, and we're typing, so we're going for all the regions we want. We make sure we got everything installed, otherwise we die out of it. Right here, see this? This line actually is taking a blueprint or a template called detect labels and generating an actual PS1 for us. That PS1 that I showed you originally, which had the find rec in it, that was generated from the template. Right? So you can pick it through the GUI if you want, but if you want to, we already have a find command that'll just actually pick the template you want, stick it somewhere, you can edit to your heart's content, tweak it, tune it, rock and roll. So in this case, we actually just took it straight as it is. I don't make any modifications to it for this demo at all. Yep. It takes a blueprint which has a set of, go to it, like example. And then it actually packages it up, and it calls publish. What does the publish do? That's, by the way, the entire code. You just run through the whole code of the publish. What does the publish do? It actually zips up everything you need and sends it out into the ether of AWS Cloud, right? You don't know where it is. You don't care where it is. It's out there. Trust me, it's there. It's got a name associated with you. And we've associated the permissions for that role to invoke the lambda. But only that role, right? That's the important thing. That's the important thing. All right. So now, okay, we got a role. We have our function out there. It's waiting to be called. But before that, let's go create a trigger. How are we going to trigger this thing? We're going to go ahead and do it with a bucket. So a bucket, as I said, is the container element of the S3 Amazon AWS service. The S3 service stands for Simple Storage Service. It's a storage service. You have a bunch of buckets, you can throw stuff in there. That's it, right? What we're going to do is our trigger is going to say, hey, when a set of files get added to this bucket, invoke the lambda function for each one of those files. Well, that's all it's going to do. That's the trigger, right? We talked about we have code, we have trigger, and we have permissions now once I finish this. And we're ready to go. We got all three of the elements necessary for function as a service. So let's now something we names. They have to be unique because it's a shared space. You do HTTPS to them, and they got to be lowercase. That took me like an hour to figure out the lowercase part. Why isn't this working? Demo buck. All right, and Hey, I just have to have names that are easy for me to remember. Send demo fun is my function name. That's right. All of which can be triggered. All right, that's it. So now we're set. We're done. We have now set ourselves up for success. The rest of this is just trying to prove that it actually works. So now let's see if it actually does work. Let's see if we can actually work. All right, so the first thing is we're going to go upload a Serverless image. Upload image, dash bucket name. I know I could do this all in one script, obviously, but it's so much more fun to type. Buck. And I do need an image folder, because this is where I'm going to upload from. Temp, PS, detect labels, images. Woo, progress, yeah. They all uploaded. In theory now, the Lambda has been invoked. We don't see it, right? This is why it's different, right? It's a trigger. And now it should show up in 3 places. All right, 2, but I'll show you 3 ways to look at it. It should show up in the CloudWatch logs, right? So we should see the log. We're going to log what we did. We have code in there to actually make sure we logged. We're good buddies, right? It'll show up on tags on the images themselves, because remember, we added the intelligence, those tags to them, right? So let's first make sure in Power, but before we look at both PowerShell version, well, it shows up that way. The third way to access, there's actually 2 places, and the third way to access it's with my PowerShell instead of going in. Yeah, I said 3, and then I tried to back out of it, and you caught me. I thank you. Oh, hello. I don't know what that is. There it is. Let's get the demo results. And I think all I have to have is this is why I actually love making sure my scripts have comments. Dash bucket name. Send demo buck. 1, 2, 3. Retrieving the tags. And there we are. Look at that. Okay, so in theory, one of the images shows a human who's performing, or we think it's performing. There's some plywood, some wood, people, and a cup. Clown, or the human's the clown. And the next one we have a koala, a wildlife animal, a koala, that's right, and it's adorable. Just to make sure that it's not lying to us, let's see what we've got here. Somewhere in here. There it is. There you are. Hey. This is the performer. He looks like he's performing to me. We're not quite sure what he's performing. That's not the. This is wood. This is cup. This is adorable. This is the one image. There's 2 images. You can't take these people anywhere. There's your koala. How's that? Not as adorable. All right. Now, the other place to look at it, I'll show you here is, here we can go to, CloudWatch. Let's go to the S3. Remember I said it was attached to the S3 somehow. Hello. Come to me. I don't want to create a bucket. There it is. Send demo buck. That's our bucket, right? Junior. Let's go for the junior guy. And if we take a look at the properties, we have storage class encryption metadata. So it's got a bunch of properties on it that we're not talking about here just because time. But if we take a look at tags, notice there's 10 tags. Look at tags, and there they are. See? Human, plywood, which was accurate. Performer, wood, et cetera. I don't know where the dairy comes from, but we're just going to leave that one alone. Everything else I can explain away. But overall, it's not bad. It's certainly better than I'm going to do in my home garage. All right, so, so that's the essence of it. That simply says, and I can show you the CloudWatch logs, but it's going to show you exactly the same thing. So that's the net that says, okay, that's what a Lambda looks like, right? Again, you've got a piece of code that you want to run. That's your raison d'etre. That's what you're there. That's really what you want to focus on. That's your core value. You have a trigger. In this case was the file getting uploaded to an S3 bucket, right? And then you have the permission sets. Hey, by the way, we also set permissions on the S3 bucket, so it was allowed to call the Lambda, because otherwise it wouldn't be allowed to call the Lambda. So we actually have 2 or 3 sets of permissions we actually lined out in the demo. We didn't want to go through all of them. All right. Any other questions on that? We're going to hit the next one. How much time do I have? I got 9 minutes, yeah? All right, good. We can do this. All right, that's functions of service. Infrastructure deployment. We're going to look a little bit ahead at infrastructure. Originally, it was back to SDKs, CLI, as they actually deployed infrastructure. Everybody remembers those days? Then people got smart. We had things like CloudFormation, Terraform, other ways. It's not really, yeah, you declare the desired state, although it's not like the DSC does. It's not always reinforcing it, but nonetheless, you attempt to go to more declarative, and the engine finds some path to implement. There are some challenges with it, right, in terms of the languages, debugging, and other things. We're actually looking at going the next level up, and there's a couple of companies doing this, but we're definitely doing one. We call the CDK, it's the Cloud Development Kit, and it says we're going to leverage the full power of programming languages in order to define infrastructure. So it's no longer, so if you want to call this infrastructure as code, that's infrastructure is code. It's like, it's just code. So what's that going to look like? We're going to take a look at a language, a CDK application, and you can do it in C#, PowerShell, Java, Ruby, TypeScript, whatever. We'll run it through a translator engine, which will produce a set of CloudFormation templates, very similar to the DSC model, if you will. There's an intermediate language right here. And then we'll run the CloudFormation engine, which generates all the instances and resources in AWS. Everybody familiar with CloudFormation? It's just a YAML and JSON-based file that defines all the resources for you and how they hook up and the permissions and everything. Right? It's how you define your system. Yeah, it was before ARM, but yeah, but it's exactly, yeah. We call these things, actually, instead we're going to call constructs, which are implemented essentially as classes in each language and can be reused. You have base class for most of the programming elements you use. Yeah, and because it's a real language, and it's an idiomatic experience in that language, you get all these other benefits. We have a few minutes, so I'm not going to go through it in too much detail. I'm happy to talk about it after if you want, and I want to show you a little bit of the results before I have to get out of here. There's 3 levels to it, if you will. There's the raw resource, which is actually auto-generated. So we look across AWS. We actually auto-generate our commandlets at AWS also. So we actually look across all of AWS, and we auto-generate a set of constructs, so you have complete capability at the low level. Now, it's nice if we have a little more intelligence, which is a little more idiomatic for the language. These might be a little harder to get your head around. The parameters might be complicated, might be more than what you like. This gives you a much better experience. And this one, the reason we mentioned this one is it's opinionated, meaning that we make choices for you. Your permission set will be, you're going to create a VPC. Here's the permission set you're going to have, right? And of course, an enterprise can take advantage of this and actually create their own opinionated constructs that are enforced across their enterprise. Make sense? And they can access them in their usual toolkits. All right, let's see if I can show you. We actually had this thing prototyped. It's layered over .NET, a .NET implementation which shifted under us. So I'm going to show you the results of the code that was and what we used to produce it before instead of running it in real time for you. All I have to do is file, open folder somewhere in here. Do you want to save changes you made to detect label? Don't save. Whatever it was I did, I didn't mean to. All right, this, these 434 lines are the JSON file which they have many times been written by hand. Lovingly crafted, very hard to debug. Go with God. It's non-trivial. Some people try to generate these in their CI/CD pipelines. It's non-trivial. This is to set up a VPC network, Large Private Compute Network. Look at all those wonderful lines. Somewhere around line 230, we actually get to saying, oh, let's create a load balancer. We're going to have a load balancer. We're going to have a fleet of instances. So this is a set of EC2 instances that you can leverage to scale up and down and grow as you wish. So these, I mean, a fleet is a high-level concept, right? You know what I'm saying? But it's still not the experience I would like. You can do this in YAML too, if that's your thing. We set the instance role, profile, blah, 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 blah. Still on fleets. Oh, some database. Yes, we actually got a database instance. And just for the heck of it, we decided to add a remote desktop gateway. You can actually remote into this beast. OK, what is the code when we're looking here? Wait, nope, don't have it up anymore. If we were looking at constructs, what is the experience we want to have? And this was generated from this code in our prototype. This is the experience we want to have. As a PowerShell user, I want to be able to say something like I do with DSC. I have a set of constructs. We call it a stack because it's the full stack, right? What do I want? Here's my VPC network. Remember the 234 lines? That's them. Those are the two things you really have to specify. That's it. That produced the 234 lines. I can understand that. Right? I can get my head, I can debug that. I get IntelliSense with that. This is why the idiomatic experience is so valuable, right? It embeds it. Here's my load balancer, right? VPC subnet, notice we attach it. We talked about the external block. Notice the forward reference to the fleet, which we haven't actually defined yet. We have the desktop gateway because we're going to do a 2-pass on this and actually generate after. Fleet? No, this is a construct. If you think of these as DSC resources, you'll come pretty close.
DSC resources is property value, it's a string, or it's an integer, or it's a command.
No, it has properties here, and it's the resources that is this level, right?
Yeah. I meant the one above it. Line 71.
Bum, 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 bum.
Equals that fleet. And a PowerShell content, what is that?
That. It's a reference. Reference to that class, instance, specifically. OK. Great question. I just want to make sure I had answered it. So we have, but it's cool because it's a forward reference, right? Because we're going to go through it again. We're just going to hang with it and find out, and then it's defined. And then we have the database. And that's it. That's the whole set. Now, you can get your head around this stack and debug it, right? And then we run it. It turns out just like DSC. No ops commerce stack. This is the name of our little function thing. It takes parameters. Right? You got a param block. We actually took the DSC model, which we thought was pretty good, but shifted it to being, let's do a DSL that's specific to creating infrastructure. What would that look like? What would change about it? What would we like about it? We haven't had dependencies and stuff into it. Anyway, so there you are. Yeah, you run it. We import the AWS CDK DSL. We import a set of resources. This is the resources. You can always go from a gallery, everything else. So CDK, summation. We will have a summary because I've got, I think, under a minute left. So cloud computing. It's a rising tide. Get on board. It provides reliable, rapid innovation at a highly reduced cost. We went through specific instances of the cost, so people got a better flavor for the reality of that. Remember, 75% performance improvement, 60% reduction in cost for a few of these guys. Whole different world to live in. We talked about functions as a service being the epitome of focusing on just your core value and letting us take care of everything else. servers, the scale, it's all open. It is today's up-and-coming tech. There are some challenges with it right now. You might want to back off containers sometimes. That's OK. But don't lose sight of where it's going. And then we have the ability for idiomatic cloud architecture definitions. And that is a wrap. Yes?
Your CDK, do you get IntelliSense when you create that thing?
Should. VS Code. Yeah.
We were talking about what's the difference between that and a Terraform example. You get access to the full PowerShell language. You could add a PowerShell for loop in there.
Oh, yes. No, you can put everything. It's PowerShell. It's complete PowerShell. You get everything the language has. You get the modules, you get the distribution mechanisms, you get packaging, you get debugging. You can do a for loop. Yeah, how many, I don't know. I don't want more than one VPC, but if I wanted n of them, I could do a little for loop around it, right? I could do an if. I could reach out. The right-hand side, like with DSC, could be a full-blown expression that goes off to an S3 database and sucks down a credential. In fact, he actually does that in the example that actually shows there's an access. I am past my time, boss. All right, thank you guys. No, I don't think so. Thank you. We're done.